Assalamualaikum and a very good morning. Here comes again I introduce myself, teacher Umi Farah Akila. Today we're going to continue our lesson in topic radioactivity. But we move on to the next subtopic, which is ionizing radiation and non-ionizing radiation. For today's lesson, we're going to cover only one learning outcome, which is at the end of this lesson, students should be able to differentiate the three types of ionizing radiation in radioactive decay. From previous lesson, I believe you guys should still remember what we have learned about radioactive decay, right? Okay, for today's lesson, we're going to highlight what is ionizing radiation. And I'm sure you guys also must ever heard about alpha, beta, and gamma. But we never knew what really they are, so we're gonna discuss about these three types further in today's lesson. Have you ever heard about ionizing radiation? What is ionizing radiation and how this ionizing radiation happen? So first bear in mind what is ionization really are. Well, it's about turning a neutral atom into an ion or a charged atom. As you can see in my slide, when radiation passes through the neutral air molecules that it collides with, and the air molecule turns out to be an ionized air, this is what we call ionization. So, how is this happen? From first to second picture, you can see that electrons have been knocked off out from an atom. To be able to ionize this atom or molecules, only particle or electromagnetic wave that have enough energy can do that. So, this can be done by alpha, beta, and gamma ray. From this, we can get to know that what ionizing radiation is all about. Ionizing radiation is radiation that traveling as particle or electromagnetic wave that carries enough energy to detach electrons from atom or molecule. In this case, it can be proton and or electron or anything with sufficient energy to pull out an electron out could be considered as ionizing radiation. If there is ionizing radiation, how about the non-ionizing radiation? What is non-ionizing radiation? Okay, let me tell you. The meaning for the non-ionizing radiation is radiation that does not have enough energy to ionize a neutral atom or molecule to become ionized molecule. So this is we call non-ionizing radiation. Let me give you some example in the next slide. On the electromagnetic spectrum, we can see that the electromagnetic with lower energy such as radio wave, microwave, infrared rays, visible light, and ultraviolet ray are non-ionizing radiation. It is because when light scattered off an electron, it doesn't have enough energy to remove them. So all of these will be considered as non-ionizing radiation. While electromagnetic waves with higher energy such as X-rays and gamma ray are ionizing radiation. The three types of radioactive radiation are alpha radiation, beta radiation, and gamma ray. Each of these types of radiation have different characteristics. So, alpha, beta, and gamma can do all this, but it turns out that alpha does it easiest, followed by beta and gamma being the worst in ionize. Now, let's see why. First, let's look at alpha radiation. We should remember that alpha radiation consists of alpha particles which are basically a helium nucleus that made of 2 protons and 2 neutrons. So thus it is positively charged because of the +2 charge. It makes alpha particle is in big size, heavy and slow moving. Now let's look at beta radiation. Beta radiation consists of beta particle. A beta particle is a higher speed electron and is thus negatively charged due to the smaller size of its electron. Finally, we have gamma radiation. Gamma ray are high energy electromagnetic wave and it is not electrically charged, so it is neutral. Gamma ray also don't have mass. We move on to the next characteristic, which is ionizing power. Here I will explain why I say alpha the easiest or the highest in ionizing power to ionize an atom and gamma is the worst one or have the lowest power in ionizing. We know that opposite charge will attract. So as the alpha goes past the atom, it doesn't need to touch the electron to knock it out as long as it can get close enough to pull out electron from the atom. While for the beta particle, we should remember that beta is an electron, same charge as the electron that it wants to be knocked out. So we know that like charge will repel or push each other. In this case, beta particle is going to repel the electron in the atom. It just go -1 charge compared to the alpha +2. So here beta particle need to get much closer for its electromagnetic field to push on the electron and cause ionization. Lastly, for gamma ray. Gamma ray is an electromagnetic wave and it has no charge. So it must to directly hit with the tiny electron to cause ionization and hence it won't cause ionization as often as alpha and beta. So here we can conclude that alpha is the highest power in ionizing and it has a large positive charge, so can cause ionization even when it quite far from an atom. Beta is the next best with the moderate one, and lastly is gamma ray with the low power in ionizing. When comparing the penetration power of radioactive radiation, we can see that alpha radiation is the lowest since it can be stopped by a piece of paper. Then, beta radiation has a higher penetration power than alpha radiation because it requiring a piece of aluminium 3 mm thick to stop it, while for gamma ray has the highest penetration power since it can only be stopped by lead of 10 cm thickness. Next characteristic is deflection by electric field. In electric field created by parallel positive and negative plates, alpha radiation is deflected toward the negative plate due to its positive charge, and beta radiation is deflected toward toward positive plate due to its negative charge. But why these two particles have different situation where alpha not easily to deflect, while beta radiation easily deflected? This is because of the mass, where alpha is heavier than the beta particle. And for the last one is gamma ray, that being neutral, so it does not deflect it and move straight forward. Lastly, our last characteristic is deflection by magnetic field. When passing through a horizontal magnetic field, alpha radiation is deflected upward due to its positive charge. Beta radiation is deflected downward due to its negative charge. And gamma ray again is not deflected because it is neutral. For alpha and beta can be explained using the right-hand slat rule to determine the direction of the particle. There are three parts which are fingers, thumb, and palm. Fingers will represent the direction of magnetic field. Thumb for direction of particle, and lastly palm is to show you the direction of the particle is deflected. But for this case, there are two charges, positive and negative. So alpha particle will use the same with the direction of slat, while the direction for the beta particle is opposite with alpha. Not to worry all this because you will going to learn further in Form 5 syllabus. For now, it is enough for you to remember where each of these radiation is deflected, either upward, downward, or move straight forward. Okay, now here I attach some activities to test your understand and to evaluate either our learning outcome for today's lesson is achieved or not. Okay. This table shows the difference between the three characteristics. Okay, I ask you guys, if alpha radiation is positive, then beta radiation is negative, while gamma ray become neutral. And for the penetration power for the alpha radiation is copper, and for beta radiation is aluminium. And the highest penetration power is gamma ray because it needs 10 cm thickness of lead. The next one, alpha radiation has the high ionizing power. For beta radiation, it's only moderate, and the lowest one is gamma ray. For alpha radiation, when it deflected by for the characteristic deflection by electric field, alpha radiation is positive charge, so it will deflect it to the negative plate. And for beta radiation, which is negatively charged, will deflect it to positive plate. And again for the gamma ray, because of it neutral, so it will just straight forward. And lastly, the characteristic deflection by magnetic field. For alpha radiation, it will deflect it upward, and beta radiation will deflect it downward. And again, and again, gamma ray will go straight forward. So that is the end of the lesson. Thank you for giving attention, and we will see again in the next video. Don't forget to click on this link for your kindly feedback. I want to know what you already know about this topic, what you want to know about this topic, and what you have learned from this topic of radioactivity. Thank you.